All right, section 6.1, day 3, right? So we're going to just finish up the last little bit that we have for today. At the very end, it's kind of an interesting problem. There we go. Again, this is a section C kind of type of problem where it's an unusual maybe application, not so much a analyzing students' work kind of problem, but an unusual situation kind of question that will sometimes occur in a section C problem. If we take a set of numbers equivalent to 1/3, so let's just pause right there and take that information and ask ourselves what that means. So what is a value fraction that's equal to 1/3? Think small numbers because we're going to need them to be small later. 2/6 is fabulous. What else? 3/9. And let me also introduce the idea that we could say negative 1 over negative 3. And I'm going to put negative 2 over negative 6. And of course, we have infinitely many things that we could write down. Okay, so that's the first portion of the sentence, a set of numbers equivalent to 1/3. And then it says that we're going to graph them as points on an xy plane so that the numerator is the x coordinate and the denominator is the y coordinate. So this is going to become the 0.13. This is going to become the 0.26. I'm going to have 3,9. And then this is why I wanted the negatives, is so that I could have a little bit more of a balanced look on my graph. -1, -3, and -2, -6. Okay, so as you're working through a problem, if you would have read this whole thing straight from top to bottom, you probably would have looked at me afterwards and said, I don't know what it's telling me to do. If you'll break it down into smaller pieces, you often know more than you think you know, okay? So that would be an example of this. And the question is then, if I plot those 5 points, what kind of graph will I get? So we're going to take those ordered pairs. Actually, I think I'm going to try and copy and paste them to the next page. We'll see. Most of that got copied. So I'm just missing my 6 from here. So we're going to plot these points. And I think I'm going to I think I can use a bigger grid. Let me try. Nope. That one might work. Be easier to graph, I think. If not, we'll find out pretty quick. All right, so I've got my XY ordered pair graph. I may not end up plotting all the points. That may not be necessary to see the overall image I'm looking for. So I need the 0.13. Okay, I do think I need a grid that's smaller. It's just not going to work. That one. All right, so we'll plot 1, 3. So that would be here. I have 2, 6. That's here. So I'm at a height of 6. This is a height of 3. And I have 3, 9. So 9 would be here and here. Actually, let me label them as numbers since the grid marks are already marked. 1, 2, 3. All right, cool. And then I'm going to do the same thing with the negative ones that I have. I have -1, -3. So negative 1, and then I have -3. And I have -2, -6. All right. What is the shape that's being created by these dots? Looks like a line, right? We'll get a little more specific in our description of it, but yeah, I agree with you. It would appear to be a line, and I may not get my line drawn very well. That's not too bad. We'll go with it. So it appears to be a line. There is one caveat to that. It feels like you can't always just connect dots and make graphs. I mean, that doesn't always work, and I understand that. But some of those are just not as nice of values, but they still would have the ratio 1/3, right? So maybe I have something that's between 1 and 2, but still the y value is appearing to be 3 times as big. And that actually works for all but one point. There is one point that I should not be going through. Does anybody know what it is? The origin. The origin is definitely 0/0, right? And that's not going to be equal, like if I said it that way in terms of a fraction, that's not going to be equal to 1/3, agreed? So I really should have sort of this open circle here at the origin. So I'll just make mine in yellow just to distinguish it. The question actually asks me, what type of a graph do we get? So we get a line. The line slope is actually 3, right? It's got a steepness of 3. A line with slope 3, except there's a hole at, and you can either say the origin or 0, 0. That's the image that I get when I create this set of ordered pairs. Any questions on that one? Yes, ma'am.
How do you know when to mention, like, what are those?
Well, it's anytime you start to connect things, you should ask yourself whether it makes sense to do that. For example, if these actually represented amounts of money or something like that, I can't really connect them because there's not infinitely many coins that represent every value between, say, $1 and $2. So it doesn't necessarily make sense to connect the dots. Here, the dots do connect because I can take a ratio and see that the ratio is still going to be 1/3. So, for instance, if I took the value 1.5 and I said, well, what height am I at 1.5? I'd find out very quickly I'm at 4.5, and 1.5 over 4.5 is still 1/3 and equal to 1/3. So being aware of what happens at 0 is often sort of a red flag thing. Zeros often give us problems. Not always, but they often do. So it's kind of like that. You're looking for things that might give you issues, and the in-between points don't, but the origin does. Yeah. All right, so that finishes up for us section 6.1.